Hey guys, welcome back to my YouTube channel. Today in this video I will tell you about Mario Bros clock. Super Mario World on the SNES was probably one of the games my brother and I played the most in our lives, so the emotional connection with the plumber starts there. The first games of the franchise on the NES were revolutionary and represented a great relief for the gaming industry that was going through a bad phase in the first half of the 80s. This article guides you, even without experience, to create an animated Mario clock that can be a retro decorative object for any environment. Further, these are the supplies which are used for this project. ESP32 dev board AliExpress. If you want a ready to use display controller board, consider the ESP32 Trinity RGB LED matrix 64x64 link 1 or link 2, both from AliExpress. Firmware, more details below. Power supply 5V recommended 3A or more AliExpress. Step 1, the concept. In 2022, right after I created my first project Pixie, I was thinking about what could be the next project. I saw that some makers were using a LED matrix to make several projects and thought that maybe I could make a wall clock with this matrix. And then the idea of clockwise came up. The idea of clockwise is to be a smart wall clock where we can change the theme of the screen and add widgets that make sense for our context. Think of it as a smartwatch but on the wall and with lower resolution. One of the first clock faces I would like to have was a Mario Bros one in which he stands on the stage and hits the blocks to change the hours and minutes. I remember seeing and loving this skin in the good times of Pebble Watch and always wanted something similar to this. I mean, the idea was so good, I would like to use it somewhere else. The LED matrix is controlled by an ESP32 and that is what I used in the initial stages of development as shown in the picture above. Step 2, my own PCB. After I made the base code for the clock, I needed a PCB. I really wanted to hang the clock on the wall, so I started to prototype my first PCB. I bought a low power laser and adapted it to my 3D printer so I could design the board that would control the display. This design worked perfectly, although it needs some improvement. You can find it on GitHub. Going pro with the PCB. Tendai has been a great platform where makers from all over the world can create and sell their projects. Brian Law is one of these guys. I met him on social networks a few years ago, and since then he has been working on the ESP32 Trinity, a tested and ready to use board to control these displays. Step 3, firmware. If you don't want to go into the details of how the code works, setup, configuration, but just want to see it working, I have good news. Thanks Brian for that. You can use the Mario Bros clock installer to upload the firmware without having to install anything and without making any effort, as it is already compiled. Just plug the ESP32 into the USB port and click the P switch to flash. Configuring Wi-Fi. The first time you run it, you need to configure the Wi-Fi. For that, connect to the clockwise Wi-Fi access point with the password 1234567 via your smartphone or laptop. Click Configure Wi-Fi and select your AP. Put it in your password and your time zone and save. About time zone, Wi-Fi manager is responsible for collecting the time zone parameter used in the clock to show the time correctly. Step 4, source code. I usually use platform IO to develop the firmware for my projects. If you don't know it yet, I recommend you to give it a try, but for this article I decided to use the Arduino IDE to make things easier. The structure was composed of 3 folders explained below with the tree of files. Clock face contains the graphics, font, icons, etc. and the implementation of Mario. Commons contains General utilities such as date, time, and Wi-Fi configuration. Engine contains implementation used by the display in general, like functions to draw the scenery, sprites, events, etc. With this structure, it was possible to assemble the clock that looks like the image attached. Basically, we have the scenery with the static objects. We have two sprites, Mario and the blocks. Mario jumps every minute and hits the block. And the sequence of events is as follows. Step 5. IDE setup. Before running it is necessary to install some libraries, all of which can be installed from the Arduino Library Manager. ESP32 Hub 75 Matrix Panel. 12 SDMA search for ESP32 Hub 75 Matrix. ADF root GFX search for ADF root GFX. Fast LED search for fast LED. NTP client by Fabric Winberg search for NTP client. ADF root bus 10 just search for the same name. Time by Michelle Margolis search for time lib. Wi-Fi manager by TZAPU search for Wi-Fi manager. Altogether, with all the libraries installed and the correct board selected, simply upload it and it should work. After that, follow the instructions provided in firmware section to configure Wi-Fi. Step 6. 3D printed case. To make it easier to hang the clock on the wall, I created a simple case on the Tinkercad. To be honest, 3D modeling is not my strongest skill, but it worked well. Just an advice, this case was modeled thinking in the display I have here at home. I don't know if it will be compatible with all display models. The whole position may not be the same. I liked the case because it is even easier to manipulate the display. Step 7. Next steps, being able to change the clock face via web serial API. I would like to create a web app where you could update the firmware by just selecting the clock face you want, create the notification widgets and display them on the watch. They could be configured in the web app itself. Integrate MQTT into the watch so you can receive these notifications from anywhere. Create more block faces. The project is open source. If you think you can help me to create more features, please feel free to contribute. Comments about ideas of new clock faces are welcome.